Okay, good day. We'll be talking today about a set. So we have here a definition of a set. The set is simply defined to be a collection of objects whose contents can be clearly determined. So when we talk about set, a set is simply a group of different elements. It is composed of different numbers. So here in a set, we have the elements. The elements or members are known to be the objects of the set. And we are using capital letters to denote a set. So here, for example, we have set B. This is an example of a set wherein it has three elements. The elements are A, B, and C. So if you will be asked how many members or elements does set B have, then there are three objects or there are three elements or three members of a set. Now there are different ways to represent a set. So sets are commonly given names and usually they are expressed in capital letters. So for example, we have this set A. Set A has four members and the members are 1, 2, 3, and 4. So again, a set is expressed in capital letters. A set is known to be an empty set or a null set if a particular set has no element or it has no, let's say, prescribed elements. So this is usually the symbol of an empty set or a null set. Okay, so we have this bracket and we have this null set. These two are used to denote that a particular set is an empty set. Then we also have this notation. So here, the notation, this is known to be an element or it is known to be a member of a given set. It is an element of this specific set. So in this example, we have 2. 2 is an element of this set. So in expressing this in terms of notation, if you are going to read this, this is 2 is an element of this specific kind of set. It could be set A, it could be set B. Wherein, it means to say that 2 in this specific element is a member or an object of a specified set. Then this symbol is known to be, it's not an element, which means to say it is not a member of a set. So we have here an example. So in this example, we have A. A is obviously not an element of this specific set. So here we have the elements of this particular set. We have 1, 2, 3, 4. And your A couldn't be found in this kind of set. Therefore, A is not an element of this set. Okay, let's go to the different ways of describing set. So we have word description, we have the roster method, or this is known to be the listing method, and we also have the set builder notation. Okay, so when we talk about word description, this is usually expressed in terms of phrases, or it can be expressed in terms of mathematical sentences. So for example, we have here the set of even counting numbers less than 10. This is an example of a word description in terms of describing a given set. Then the roster method, going back to this word description, if you are going to express this in terms of this way, we have the listing method or also known as the roster method. You are just going to identify what are those numbers which are less than 10. And it is a part of the counting set of counting numbers or natural numbers. Then basically, you're just going to list them down. So what are the numbers which are uh, lesser than 10 or less than 10? We have here 2, 4, 6, 8. So by listing down the elements of this particular word description, then we have here now the roster method. We have 2, 4, 6, 8. Okay, so this is the roster method or the listing method. Then we have here another way in representing a set. We have the set builder notation. Okay, so it is uh, using your bracket. So here we have here set A, for example, is a set of all x wherein x is an even counting number less than 10. So as you can see, set builder notation is more defined from the given word description and roster method. It is specifically defined. So from the given set builder notation, together with your roster method and word description, all of this, they mean the same thing. So this symbol, as you can see, this line here, this vertical line, this is read as such that. Okay, so I repeat, we have the three ways or methods in describing a given set. So we have word description, we have roster method, and we have set builder notation. Okay, so we have here your set of numbers. When we talk about sets of numbers, maybe you are familiar about your counting numbers, your whole numbers, integers, your rational numbers, irrational numbers. So basically, we have these different sets of numbers. Okay, so when we talk about natural numbers is also known as the set of counting numbers. So natural numbers are the usual numbers which are used for counting. So we have here 1, 2, 3, 4, and so on and so forth. So this is the set of natural numbers or counting numbers, and it is usually denoted by capital N. Then we have whole numbers. From the set of your counting numbers or natural numbers, if you're going to combine 0, then we call it whole numbers. Okay? So the set of natural numbers plus 0, it will comprise a bigger set of numbers, which is known to be the whole numbers. Now, we also have here your set of integers. So when we talk about set of integers, we have the set of whole numbers and their opposite or the inverse of the numbers. So that is now the set of integers. So if you are going to analyze it here, by looking at the given example, we have 0. Then here we have your natural numbers, and your natural numbers are all positive numbers. Then getting the inverse of these natural numbers, we will be getting the opposites, which are the negative sign numbers. So if we have the set of whole numbers and the opposites, we will have now your integers. Okay, now we also have your set of rational numbers. So when we talk about set of rational numbers, these are usually expressed in terms of a fraction. We have A over B. It is the set of numbers which are usually expressed as ratio of A and B, wherein B should not be equal to 0. Okay, for example, 1, 1 half. 1 half is an example of rational number. A here is 1, your 2 is B. And as what I told you, based on the definition of rational number, your B should not be equal to 0. So that this kind of fraction is defined. Remember that a rational number or set of rational numbers, it could be terminating and non-terminating. 1/2 is terminating because if you are going to express 1/2 in decimal, it is 0.5. While 1/3, 1/3 is a rational number which is non-terminating because it has no end. Approximately the value of 1/3 is 0.3333. Okay, that is the approximate value of 1/3. Then a set of rational numbers, as what I told you, we have A and B. It could be an integer wherein B should not always be equal to 0 because let's say we have 1 over 0. 1 over 0 is undefined. You cannot have the value of 1 all over 0 or 3 over 0 or negative 1 all over 0. But if we have 2/3, let's have 5 over 7, 1,000,000 over 3. Those are examples of rational numbers. Then we have here another set of number. We have now irrational numbers. Irrational numbers, it cannot be expressed as ratio of two integers. So for example, here we have the value of your pi, and this pi is used in computing, for example, the surface area, the area or the volume of sphere. So this is an example of irrational number. Because when we talk about ratio of integers, integers could be negative and positive, but they must be whole numbers. 3.1415 is not an integer. Always remember that. 1.5 is not an integer, but it is a positive number. An integer, as defined from the meaning, it is the set of whole numbers and the opposite. Okay? Now, if we are going to combine the set of rational numbers and your irrational numbers, then we will have now the set of real numbers. Okay? If we are going to combine both. So, let us try to look at the representation of the set of whole number system. Okay? So, we have here your natural numbers. As you can see, we have here your positive numbers. Okay? Positive numbers, they are not in fractions, because natural numbers are numbers which are being counted. Then we have here the set of integers. From the set of integers, you're going to combine your set of natural numbers. So, if we are going to combine your set of natural numbers, including 0, here we have 0, then we are going to have now a bigger group of numbers known as integers. Okay? Now, when these integers, natural numbers, together with 0 are expressed in fractions. And always remember that from the meaning of rational number, your ratio of integers, wherein your b should not be equal to 0, so that it is still defined. So if we are going to combine this, then we will have now this bigger set of numbers known as rational numbers. Okay? Then we also have here your set of irrational numbers. For example, we have 3 the fourth root of 32. We have negative 2 square root of 5. Then the negative cube root of 24. We also have the pi. These are all examples of irrational numbers. Okay? Because we cannot express them in the form of a over b, or the ratio of two integers. Now, this set of rational numbers, when combined to both your irrational numbers, when both of these are combined, it will comprise now a bigger set of numbers known as the set of real numbers. Okay? So, let us go now to the next. Let's have now inequalities and set representation. So always remember that there are different methods in describing a set, we have word description, we have set builder notation, and we have roster method. So for example, here, we have here your inequality symbol. We have x is less than 4. So this is now the word description. We have x less than 4. Now, in terms of set builder notation, it can be expressed as the set of all x such that x is a natural number and less than 4. If you are going to read this, I'll repeat. The set of all x such that x is an element. This symbol again is read as element. I'll repeat. The set of all x such that x is an element of natural number and less than 4. Okay, roster method again. Roster method is simply listing down what are the elements of this description. So, thinking about it, natural number less than 4, we have 1, 2, and 3. So, we have the elements 1, 2, and 3. Remember, as what I mentioned earlier, word description, set builder notation, roster method, they are simply the same. Okay? Another example, we have here, x is less than or equal to 4. So, if you're going to express that in set builder notation, again, the set of all x such that x is a natural number and is less than or equal to 4. Remember this symbol. This is read as less than or equal to 4. If you're going to read this symbol again, this is read as the set of all x such that x is an element of natural number and it's less than or equal to 4. So, roster method, you're going to know now what are the elements or the members of this description. So, we have 1, 2, 3, and 4. As simple as that. Okay? Now, let's go to this. Okay. We have the word description. X is greater than or equal to 4 and less than 8. Okay. Now, in set builder notation, this would be read as the set of all x such that x is a natural number greater than or greater than 4 or less than 8. Okay, so getting now the listing method of this or the roster method, we have 4, 5, 6, and 7. Okay, now let's go to cardinal number. When we talk about cardinal number, this is simply counting the number of elements in a set. You are just going to count. So here, the symbol, the cardinality of set A or n of A represent the cardinal number of set A. So if you will see this, you are just going to count the number of elements present in a set. When finding cardinal number, don't count repeated elements. So if there are elements which are being repeated, then they would only be counted as 1. Okay, so let's have an example. Find the cardinal number of the following. So we have set K. Set K has the following elements. We have 2, 4, 6, 6, 8, 10, and 12. As mentioned, when we talk about cardinal number, elements should not be repeated because repeated elements are just counted as 1. Then we have here set M is equal to 2. Then we have here an empty set. So the end of A of set K here, we have 6. Why 6? Because we have 1, 2. Remember, just count this as 1 element. So we have 1, 2, 3, 4, 5, 6. So there are 6 here, this is now the n of k, which is equal to 6. Then B, there's only one element of your set n. So we have n of n equals 1. Then here, the n of an empty set or the cardinality of an empty set, it is equal to 0 because there's no specific element that can be found in a null set or an empty set. Okay? So that is talking about cardinal number. Remember that if we are talking about the cardinality of a set, it should always be a unique element in a specific set. If there are elements which are repetitive, they would only be counted as one. Okay, let's talk about equal sets. So equal sets means to say that the elements that can be found in two sets are the same. Remember, the number of elements found in two sets are the same. Okay, so then we write equal sets as this, A equals B. At the same time, it is known to be an equal set aside from they have the same number of elements, the elements are simply the same. Okay, so that is known to be an equal set.